Let's discuss a question from theory of machine. This is a question of vibration. We need to calculate the natural frequency of system. So looking at this system, obviously the spring in the given figure, the spring is in unstretched condition. So because of the weight, this bar will just turn anti-clockwise, and there will be a, so this bar will turn in this way because of the weight, and there's a hinge point here. So this bar will just, instead of like this, it will just move in this way, and the spring will get stretched. So in equilibrium position, if we just recall, okay, in let's do a force balance in equilibrium position, because that will give you an idea about. Okay, so in this state, the weight mg acts in this there's a force mg which is from the block, and this distance, deflected portion of the mass bx, the deflected portion of the spring be delta. Okay, and therefore the spring force will be acting, the spring will be in a stretched condition, it will be in tension. So the force on the rod due to the spring will be away, that is k delta. Okay, and this is due theta. So in this equilibrium position, if you do a force balance about, if you do a moment balance about O, it has to be 0. If you do a moment balance, so F into, so this F force is producing anti-clockwise moment, so F into L is the anti-clockwise moment. Okay, so I write it minus anti-clockwise moment. K delta is producing clockwise, so K delta into, it's 2L, so I'm just writing plus K delta into 2L. So yeah, so only these two are the forces because the weight of the rod is neglected. So K delta is a spring force when the spring is stretched by delta, into 2L because it is away by distance of 2L. Okay, so this is, if you cancel this, K delta into 2 is F, and F is mg, so mg is 2k delta. Okay, and now if I have to replace, now how do I find natural frequency? Always I will replace a given system with a spring, k equivalent, and mass m. Now I have to replace with this system. What I need, the original system and this system should have is that if I write down at equilibrium, the idea is simple. From this I'll write down an equilibrium equation and compare with this k equilibrium with x. Okay, so this, in this equation, when I have a spring mass system with k equivalent being my stiffness, then at equilibrium mg is k equivalent into x. So I'll just compare, write down equilibrium and try to bring my equilibrium in this form, then I can get equivalent stiffness such that this system can be replaced with a single spring mass system with the stiffness equivalent to k equivalent. Okay, so this is my thing. Now how do I relate x and delta? Because I need to bring this mg in this, it should be similar to this equation where x represents the deflection of mass m. So now x by L, because it's a similar triangle, x by L is delta by 2L. Okay, so x is delta by 2 and delta is 2x. So if I replace it here, delta is 2x, so it's 4kx is mg. So mg is 4kx. So this is the equilibrium equation for a given system, and where x is the deflection of mass. So this becomes, if I have to compare with my single spring mass system, the single spring mass system will give an equation mg is k equivalent to x. So but for the given system, this is the equation, and for the single spring mass system, this is the equation. So comparing these two, I get k equivalent as 4k. Therefore the natural frequency for a spring mass system is k equivalent by m, and as you have replaced the actual system with the single spring mass system, the k equivalent is 4k, so it's 4k, root 4k by m. So answer is D. So remember, we have just cleverly solved this problem. Just you need to just write down you need to just consider you need to just balance this in a equilibrium, and whenever it's in static equilibrium, just consider the position of static equilibrium, write down the equilibrium balancing equation, and such that the weight mg is something into x, where x is the deflection of mass. Now that something, when you compare with a single spring mass system, the equilibrium equation is this. So you are comparing an equilibrium equation of a given system with the equilibrium equation of a single spring mass system, and you get equivalent stiffness. That is the whole idea. The whole idea is to get the equivalent stiffness, and then you can use the natural frequency formula. So answer is D. Thank you.